and 1,3b today. So we're going to start with 1,3a, which is real numbers. And the number line. And I'll tell you something, if you guys end up taking Algebra 2 someday, you're going to do all this again, review, just kind of like stepping it up a little bit. So the better you can learn it now, the easier Algebra 2 will be someday if you decide to take Algebra 2. All right, we are going to talk about square roots today. Yes, ma'am. I'll do it for you. So square roots. We would say a is the square root of b if a squared equals b. Okay, so a is the square root of b if a squared equals b. Okay? In other words, if I said 6 squared equals 36, right? Then we would say 6 is the square root of 36, right? The square root of 36 is 6, or 6 squared is 36. So there's a relationship there that you're just seeing it two different ways. One with the square root, one with a squared. But they are essentially doing the same thing, okay? Just kind of the reverse of each other. So what you need to know is this symbol right here. This is called a radical. And then whatever comes under the radical is called, anybody know it? The radicand. So we're going to deal a lot with radicals. Just a heads up, sometimes I say the square root of 36, and sometimes I say rad 36, like I'm back in the 80s, this is radical. If I say rad 36, it's just the square root of 36, okay? I kind of jump between the two. They mean the same thing. You may use either one, okay? Okay, so with this idea, because I'm sure you've seen square roots before, we're going to step into what you do to simplify them. So if I tell you to simplify these radicals, and I give you the square root of 81, I'm basically saying what needs to get multiplied by itself to equal 81. It's 9, right? And your calculator helps you with these as well. So if you don't know where your radical on your calculator is, let me know. I can show you. But it's the square root of 81 would be 9. Okay, 9 times 9 gets us 81. Or 9 squared. What if I did this? Do you know how to simplify that when there's a fraction in your radical? It's 5 over 6. Basically what you do is you take the square root of the top number over the square root of the bottom number. Okay, so don't try to think, I don't know what 25 over 36 is as a number, and then the square root of it. Just break it up. What's the square root of the top? What's the square root of the bottom? This would be 5. The square root of 36 is 6. So your answer is 5/6. Okay. What is, anyone know this one? The square root of 121? That's 11, right? 11 times 11 would get you 121. Okay, and then what would the square root of 49 over the square root, of 144 be? Do you guys know the square root of 49? That would be 7, and then the square root of 144 is 12. Okay? So whether they put the big square root or two separate square roots, you do it the same way. Make them two separate and find the square root of each. Okay? Okay. So we're just going to make real quick a list of the perfect squares, which is essentially what we've been talking through. Those are all perfect squares. If you can multiply something, a whole number by itself, it is a perfect square. So 1 times 1 is 1, right? 2 times 2 is 4. So those are the first two perfect squares. What's the next one? 9. 3 times 3 is 9. What's the next one? 16. 4 times 4 is 16. Then what? 25. We're going to run out of room here. What comes after 25? 36. 6 times 6. Okay, 7 times 7. 8 times 8 is 64. 9 times 9 is 81, and 10 times 10 is 100. So this is a list of the most common perfect squares, right? This is 1 squared, this is 2 squared, this is 3 squared, this is 4 squared, and so on and so forth. If you can keep those ones memorized, maybe you want to add, we do 121, that's 11 squared, 144, that's 12 squared. Anyone know 13 squared? 169. So we rarely go beyond this, okay? But if you can just kind of keep those stored in your brain, like, yes, these are the common ones, that helps a lot when you have to solve problems like this. Keeping in mind that you are welcome to use your calculator, okay? Your calculator is okay. Any questions on perfect squares? Okay, then what we're going to do is we're going to try to estimate some of these. Okay, so we're going to say estimate the square root. Oops. All right, so for this first one, I'm going to say the square root of 34. Okay, what I'm looking for is, what is this close to? Which number would this be close to? Well, if you look at your perfect squares up here, it's close to which one of those? 36. Okay, so if it's close to 36, the square root of 36 is what? 6. Okay, is it closer to 25 or 49 from there? 25, right? It's between 25 and 36, but it's closest to 36. So if we said the square root of 25 is 5, the square root of 36 is 6, and this falls in between there, we're closest to what number? What whole number? 6, right? We're closest to the 6. So when we estimate that, we'll say it's approximately 6, or it's close to 6. That's what the little squiggly lines means, like an approximation. It's not exact, but it's close to 6. It's somewhere between 5 and 6, is another way you could think of it. Okay, what about this one then? If I give you the square root of 83. Okay, if you look at your list of perfect squares, which two are we between? The 81 and the 100. So the square root of 81 is what? 9. The square root of 100 is 10. So we're somewhere between 9 and 10. Which one are we closer to? The 9, right? 83 is closer to 81 than it is to 100. So we would say this is approximately 9, or it's going to be somewhere between 9 and 10. Okay, but closer to the 9. Any questions on that? How can you check your answer? How can you check if you're close? Plug it into your calculator, right? If I plug in the square root of 83 in my calculator, I get 9.1104. That's close to 9, okay? Whereas if I plugged in the square root of 99 in my calculator, I get 9.9. That's closer to 10, okay? So plug it in and check. Just make sure you have it. Do you all know where your square root button is on that calculator? Yes? It's the second key for your x squared. So if you have this calculator, if you hit second and then that x squared key right here, that's the square root. Don't hit the one above it, the little caret key that has the little x by it. That's for a cube root or a fourth root or bigger numbers. A square root is the one right below it. So the x squared key. Okay. Questions so far? Doing okay? All right. We are going to talk about some sets and then subsets of numbers, so like groupings of numbers, all of which are real numbers. Okay, so we're going to talk about real numbers right now, but we're going to break them into different sets. So one set is the irrational numbers. Okay, so I'm just going to call this A. These are all real numbers. Irrational numbers. Does anyone know what an irrational number is? You remember the word, right? Yeah. That's a prime number. Those are primes, yep. Irrationals. They can't be written as what? As a fraction, right? Irrational numbers can't be written as a fraction. Okay, so let me give you some examples of irrational numbers. Something like pi is an irrational number, right? 3.1415, blah, 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 blah. It just keeps going. Pi has no end, okay? So pi is irrational. Another irrational number, so these are my examples here. Another irrational number would be the square root of 2. If you plug the square root of 2 into your calculator, let me plug it in and show you, you get 1.4142135562, and it just keeps going, okay? A number that just keeps going cannot be written as a fraction. So that would make it irrational, okay? One last example would be a number like 0.101000100001, so on and so forth. There's kind of this pattern happening, but it just keeps going and it's changing. It's not 0.10101010, right? It's not a repeating. It's 10 and then 100 and then 1000. So it's changing even though there seems to be a pattern. It's just going to keep going different every time, okay? So those are irrationals. We're going to deal more in the rational realm. So rational numbers. First of all, these can be written as a fraction. Okay, which means if they can be written as a fraction, they can have two things. You can have terminating decimals. Do you know what it means to be terminating? What? The opposite of that, ending, right? If you think of the Terminator, he was there to like put an end to things. So terminating is ending. Okay, so terminating decimals would be like 2.75, right? The number stops. That would be 2 3/4, which you can write as a fraction. Or maybe it's 3.875, okay? It's a decimal that has an end. If it has an end, you can write it as a fraction. Another set of rational numbers is repeating decimals. Do you know what a repeating decimal is? Like 2.6 repeating, right? That's 2 2/3. You can write it as a fraction. Or 1.3 repeating is 1 1/3. Okay, so repeating decimals are rational. Terminating decimals are rational. Anything you can write as a fraction is a rational number. So rational and irrational are big like umbrella terms. But then under rational numbers, there's all these other subsets that we have. So all these other groupings that we're going to do here. So I'm just going to name them, and then I'm going to show you what they are. So the first under rational, okay, so we're indenting here. Number 1, a rational number. I didn't go low enough. I'm going to bump into my other stuff. We'll go here. Okay, one set of numbers here is the natural numbers. If I said count to 20, what would you do? Right, that's natural, right? It's natural to count 1, 2, 3, 4, 5. Those are the natural numbers. So your natural numbers are the counting numbers. 1, 2, 3, 4, and you just keep going, okay? Dot, dot, dot means keep going. So those are the natural numbers. The second subset under here is the whole numbers. Does anyone know what whole numbers are? What? Okay, there are whole numbers in the natural numbers. Okay, I see what you're saying there. In a fraction, that like base number is a whole number. That is true. You're saying, sorry, a mixed number. The base number is a whole number. All you have to add to your natural numbers is one number. Anyone know what that one number is? It's 0, right? Here's how I tell people to remember this. Your whole numbers are 0, 1, 2, 3, and so on and so forth, okay? So a whole number is a natural number, right? Or, sorry, I said that backwards. A natural number is a whole number. The only time a whole number is not a natural number is if it's 0, okay? But the way I tell people to remember this, we'll see if this is helpful to you or not, is the word whole has a 0. It's not really a 0, right? It's an O, but has a 0 in it. So when you think whole, think 0 plus all the natural numbers, okay? Okay, third and final of these is integers. Do you know what an integer is? What are they? Negatives and positives. So integers are the whole numbers, positive and negative. So that would be like -3, -2, -1, 0, 1, 2, 3. And you just keep going in both directions. Okay, those are integers. Any questions on that? Okay, so here's what I want to make sure you understand about these. We talked irrational and we talked rational. We've also been talking square roots today. Some square roots are irrational and some square roots are rational. I'm going to give you some. You tell me which it is, okay? If I give you the square root of 3, is that irrational or rational? It's irrational. If you plug in the square root of 3, you're going to get 1 point blah, 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 blah. It's just going to keep going, okay? What about the square root of 4? It's rational. What is the square root of 4? 2. That is natural, whole, and an integer, right? So the square root of 4 falls into the rational category. What about the square root of 11? Irrational. Okay, that's going to be a funky number. What about the square root of 36? Rational. You guys are so good. That's rational because that's 6, right? So you got to just look at, is the square root a perfect square? If it's a perfect square, it's rational. If it's not a perfect square, it's irrational. Okay? Any questions on that? All right. I'm going to give you an example. You tell me the subsets that this would fall into, as many as you can, okay? Irrational, rational, natural, whole, integer. What do these numbers fall into? This is example 3. So this is name the subset. Subsets. Might have an S, might not. Okay, so first one, the number 15. Tell me of our list, irrational, rational, natural, whole, integer. What is 15? Okay, let's start here. Is it irrational or rational? It's rational, right? This is rational. It can be written as a fraction. How can you write 15 as a fraction? 15 over 1, right? So that's rational, okay? Then think through the subsets. Is it natural? Yes. Is it whole? Yes. Is it an integer? Yes. So it is natural, whole, and integer. Okay? If you would like shortcuts for the words, I'll give them to you right now. You don't have to use these because it's just one more thing to memorize. You may write the word. But here's how this tends to work, okay? Real numbers is a big old R, kind of looks like a paragraph thing, but the 2 lines make it an R. Irrational is an I. Rational is actually a Q because the R is real. Natural is N. Whole is W. And integer is Z. I don't know why Z. Can't do I because it's irrational, so they picked Z. So if you want to use letters, that's fine as long as you know what those letters stand for. Okay? If you're not comfortable, then just write them all out. Okay, this one. What would negative 6.375 be? First of all, rational or irrational? I hear both. Look at your definitions for rational and irrational. It's a terminating decimal, right? It has an end, so this is rational. Okay, so if it's rational, then you have to look, does it fall into any of the other 3? Is it a natural number? If you start counting, are you ever going to get to negative 6.375? No, right? Natural is 1, 2, 3, 4, 5. Okay, is it a whole number? 0, 1, 2, 3, 4, 5. Nope. Is it an integer? Be careful. Integers are whole numbers that are positive and negative, right? A lot of times people see a negative symbol and they go, yep, integer, because they're used to integers having negatives. But integers have to be negative whole numbers. This is not a whole number. So your only answer for this one is rational. Okay? All right, how about this one? The square root of 81. Rational or irrational?
Rational.
It is rational because it's a perfect square, right? So it's rational. Okay. Is it a natural number? Yeah, it's 9, right? So that's natural. Is it a whole number? Yes. Is it an integer? Yes. So that falls into all of those. Okay. Last one. the square root of 82. Irrational. If you plug that in, it's not a perfect square. So this is irrational. Okay? Questions on that?